So I've been trying to learn Clojure as part of the 12 and 23 challenge from Exorcism. This is Exorcism. It's a pretty neat site for learning a whole bunch of languages. They've got quite a few in here. 66 languages at the moment. So I've been starting to learn Clojure since the beginning of the year. Go over to... Oh, actually, I'm not logged in. Let me log in first. Finished 24 out of 48 exercises. Before, when I was doing some of these exercises, I think I did a couple of them in Clojure, but in some of the other tracks that I started as well, I was just doing the exercises directly inside the website. So you can do that. You can, let's say we click on one of these exercises, we'll do this one, Pig Latin. So you can actually do this directly in the editor here, and it'll run the tests until you read the results, and you can do that right in here. But I wanted to kind of get a feel for some of the tooling behind the language as well, so that I had a better idea. I guess there's different layers of learning a language. You can learn the syntax and the semantics, and I think Exorcism does a really good job of teaching you those things, the syntax and semantics. Some of the tracks are not really well baked out. They don't really teach the language. You kind of just have to figure it out yourself. But they at least test your knowledge on the syntax and semantics. But it doesn't, unless you do it locally, you're not also learning the tooling. So that's what I also want to learn, the tooling behind the language. The editor setups and how to compile things and things like that. And then the other thing that it doesn't really teach you is how to actually build a real world thing. So I'm hoping that after I go through all these exercises on Exorcism, I can actually build something useful with Clojure and put out all the way to production, so I get a feel for development and then deploying and the whole thing. So there is this thing called 12 and 23 challenge. Clojure is the first language that I'm attempting to do. In order to put this badge on there, you really only need to finish 5 exercises, which doesn't take much to do. You can knock out 5 exercises for a language in probably an hour or so. But I'd like to actually learn the language, so that's kind of my goal. I have a tentative list of the languages that I want to learn. Let's see if I can pull it up here. That I put in the Polyglot channel in Syracuse.io. So Clojure, I put TypeScript on there. I may not make it one of my Exorcism tracks because I'm actually kind of learning it just by using it in some other projects. So OCaml is another one that I put up there, and another, again, because I'm already using it to build something, but I don't really know it that well. So Elm, I've talked about a lot. I've known about it for a very long time, but I've not really actually used it. Rust is getting a lot of hype. PureScript is like Haskell, but for the web. Crystal, which is like Ruby, but got some other cool features that I've heard about. F#, functional programming language that's similar to C#, or related in the .NET world. Go, I've been poo-pooing on Go for a long time. I don't like anything that Google produces usually, but I decided to give it a fair shot. And Julia is another one. Lua and Nim. So that's my tentative list, but I'm trying to get a good feel for a whole bunch of different languages. Like, instead of learning a whole bunch of languages that are similar to each other, try and learn as many different languages that are different from each other, so I get a feel for language design and how people go about adding features to a language and the tooling behind it. So as someone who's interested in building my own language and learning how languages work, be good for me to actually spend time with a lot of different languages. So anyway, back to the Clojure setup that I have on my computer here. What I've got is a local repository here called Exorcism. And I've got the Exorcism CLI that's in here. Let's see if it gives it help there. So they've got a little command line here. It'd be really cool if you could browse the exercises from the command line. They don't have that. You can really only download and submit it from here. But what I usually do is I go here and I pick an exercise first. So we'll do the Pig Latin one that we started here. And then I'll go and copy that command from there. And then paste it in here. And then what I'll do is I'll cd all the way into that directory. Usually I just cd to Clojure and then open up VS Code from here. Now I'm hoping, I'm really kind of understanding a little bit more about the importance of using good IDEs and such. VS Code I like using, and it suits my purposes, and there's actually pretty good tooling for most languages in it. But for instance, for work now, I've been working with Visual Studio for C# development. Typically when working with Lisp languages, people use Emacs because it's written in Lisp, and if you want to modify Emacs, you have to write Lisp, and it's really built for developing things in Lisp. And Clojure is a Lisp dialect. So, but I have not gone all the way down and installed Emacs yet. So this is just the setup that I have here. So what I do is I open up the one that I'm working on. So that's the Pig Latin one. And I know that some people have these things where you can see what keys you are typing. Let's see if I can install that first. So this will be a little adventure. We go on first. What should I search for? Key typed key indicator. I don't really know what I'm looking for. Key, I'm going to look at KPIs. Key indicator, no. Key, let's be more verbose. Show what keys being pressed. There we go. A lot of these are for testing if your keypad is working and such, but I want to, oh, here we go. PowerToys has this. That'd be kind of cool. I already have PowerToys on my computer here. Oh no, it was okay, so this was a feature request for adding it to PowerToys, but fortunately there is a link to a useful thing called KeyViz. Winget. Okay, so all this version GitHub releases. Okay, let's give this one a try, just so you can see what kind of keys I'm typing here. Do the exe here. At least it's version 1 already. That's good. I think I need to do keep. Show more, keep anyway. And then open that up. Uses Flutter, it looks like. Alright, let's give that a try. Okay, I got a flash on the screen for a second. Okay, so it's displaying on a different display. Let's see if I can change which display it shows on. If not, then I'm going to change what my primary display is. Style, modifier, color, show icon, show symbol, appearance, margin, duration, animation speed, about. Okay, so it doesn't look like I can change the display, so I'm going to change my display settings here to, or actually, you know what, I just need to move these windows over to the other desktop here. Let's do this. Okay, so I'm going to make this one my main display. Okay. And now, let's see if I start typing stuff. Interesting, okay. So even after making that my main display, it's still on the other display. Okay, let's try this again. I'm going to quit it, restart it. What was it called? Keyviz. Okay, that did a little flashing. Let's see. There we go. Alright, you can see what I'm typing. If I were to do something like now I'm typing. Okay, interesting. But if I do like a chord, like let's say I do, there we go. There's a little chord for you. Okay, that's nice. We'll go with that for now. We'll tweak some of the settings a little bit here. Let's make this just a little bit smaller. 32 is the smallest this goes to. Okay. Solid. Default. We'll go with solid. Okay. I'm not going to fiddle with that too much. Save and exit. All right. So here's my setup here. I've got the file opened, and then what I have here is something called Cavel. If I click on this REPL thing, it says click into jack in. Start your project with a REPL and connect. So jack in, then I pick the file, which is the Pig Latin one here, and it opens this other thing. I usually don't use this side one. I'm using, I don't know how this is pronounced, Line Engine. Truthfully, I'm not entirely sure what Line Engine is. I think it's some sort of runtime or environment for, or like a package manager. Not really sure. So this takes a little while to start up. There's a little kind of REPL-like thing in here, but I don't really use it. I close that out. And then I don't really need to see anything in the terminal either, so I get rid of that. I usually open up another one for running my tests a little later. But first things first, we need to take a look at what we need to do. So there is a Pig Latin README. So Pig Latin is made up of children's language that's intended to be confusing. Couple rules. If the word begins with a vowel, add an A sound to the end of the word. Please note the X, R, and YT at the beginning of a word makes vowel sounds. X-ray. Ooh, okay. That's for sure coming up in the test. They're going to put an X or a Y at the beginning of a word. If a word begins with a consonant sound, move it to the end of the word and then add an A sound to the end of the word. Consonant sounds can be made up of multiple consonants, aka a consonant cluster. Chair becomes airche. Okay. So I've got to consider multiple clusters as well. Okay. If a word starts with a consonant sound followed by QU, move it to the end of the word and then add an A sound at the end of the word. Square becomes airsquay. Okay, so in other words, QU is considered another cluster as well. If a word contains a Y after a consonant cluster, or as a second letter in a two-letter word, it makes a vowel sound. Rhythm becomes ithimray. My becomes Waime? Aime? Don't know how to pronounce that. Waime. Okay, interesting. There are a few more rules for edge cases and there are regional variations too. Alright, so maybe the better thing to do is take a look at the tests to see what kind of stuff they're actually going to be testing here. Apple, ear, igloo, object, under, equal, pig, koala, yellow. They do have an X there, xenon, cat. Okay, some clusters, chair, queen, square, therapy, thrush. Ooh, thrush is going to be having to be 3 consonants, SCH also. Okay. Y tree, X-ray, rhythm, my. Okay. So pretty much the ones that. Oh, and then we can do a whole phrase as well. Okay. So, because we have to do a whole phrase, I'm not seeing any tests here handling an empty string. Clojure does have the ability to, so strings are treated as collections, and you can kind of loop over them or do anything else with collections that you would normally do, including kind of doing head and tail. So you split off the first thing and then have the rest of the stuff come afterwards. At first I thought that would be a useful thing because you're kind of splitting off the head and the tail and then the rest of it, but I also realized that we don't really know how long that head is. That could be anywhere from 1 to 3, and then actually it could be 0 to 3. There's probably weird edge cases where it's even more than 3. But in the testing here, it's just anywhere from 0 to 3. So I think what we need to do is we basically want to check to see, does the word begin with a vowel first? And if so, just put A at the end of it. So let's start with that easy rule here. So let's assume that we're going to get first a phrase, and that we're going to need to split up that phrase into words. So I'm actually going to, so this is part of the tooling here. You can put a little thing called a comments block here, and then I can test out things on the fly here. So if I say, actually I'm going to make a little thing called defn words, and we'll just say that takes a phrase and splits into words by doing split. I think that might be in the string namespace. I think I have to do string split. This will do a quick fix here, and I can just require Clojure string stir. Split phrase. Let's see if we get a little bit of Clojure string split is called 1arg. Okay. Are we seeing any IntelliSense for how what this string thing expects. Okay, I think it expects first the string itself, which will be the phrase, and then the thing I want to split on. Usually I'll see like some pop up with an explanation of it. Let's just go over to the Clojure docs. Clojure string split. I'll keep this docs open, I can search it. So string and then the regex regular expression optional argument limit is the maximum number of splits. Okay. So it has to be a regex, so this guy just put a number sign in front of that. All right, let's test that out. So in order to get this working, I can press Alt-Enter here, and then that evaluated this entire expression. It's called an S expression. So the namespace one, I have to evaluate it to kind of tell Cavil that I'm in this namespace. Then I have to define this one. Again, that just kind of returns back this function here. And then I can do words of hello there. Give that a try. There it is. Hello there. Okay. So we're working. So that's the neat thing about the setup here is I can just real quickly press Alt-Enter and see the result of something. The other thing that it does is it automatically has some version of pair edit, I believe, is what it's called. And so what that means is I can, if I try and press backspace, you'll see that I press backspace there. It didn't actually delete the parentheses. If I press delete now, it didn't delete the parentheses. It skipped over it. And so the reason why it does that is it doesn't allow us to have unbalanced parentheses. With Lisp dialects, of course, you have all these like nested parentheses, and it can be a little tricky to keep on top of it. So there's tooling around there to keep that from being an issue. There's a couple other features that we'll see as we go along here. So let's first do, I think what we're going to want here is a cond. So a cond lets us do something where we check each condition, and if that condition is true, we execute the second part of it. So we'll do a condition followed by the expression that we want to evaluate. So the first one is checking to see if it starts with a vowel. So actually, I realized the first thing we're going to need to do is loop over the entire phrase, right? So we're going to have to do a, we're going to have to go get the words and then do a map of a function and then join it all together. Yeah, that's what we'll do. So we'll delegate some of this stuff out. We'll say defn translate word, and then we'll give it a word, and then we'll fill in the body there, and this is where we'll do most of our work then. And then in here, what we're going to do is we're just going to map over it. We could reduce it, but I'm not really familiar too well with how reduce. I know reduce in JavaScript fairly well, but in Clojure it's a little tricky. Let's see if we can do it with reduce so we don't have to do a join afterwards. So what we're going to do is we're going to reduce it into a function. So this is how you kind of do a shorthanded function. I could do a function like this, but I kind of like this shorthand thing. So the shorthand thing allows us to use the parameters of dollar, or %, rather, and reduce takes 2 arguments, so you can actually use %1 and %2. So I'm going to take each word as it comes in and reduce it into call the translate word function on it. That's going to take phrase. It's also going to take an initial condition as well, which will come before the collection. Okay. So it's going to be an empty string initially. it's going to take, okay, so this is where I don't remember which comes first, the accumulator or the word. Well, we know that we're going to need to take them and join them into a string. So we'll say string, so take the two things together. And let's assume that the first one's the accumulator and the second one is the. So here I've got the open parentheses there, and I'm going to say translate word. Now here's a little cool thing I can do. I need to get that %2 inside of there. I could just go here and delete it and then add it in here. I could copy and paste it. But I can also do something called a slurp, which is Control-Alt period. So that's slurped it into there. If I want to spit it back out, or it's called barf, I can press Control-Alt, comma, and that will barf it back out again. So now we've got a function that reduces over it, starts with an empty string, takes each thing in the phrase. Oh, actually, I need to turn the phrase into words. So we'll say words of phrase. There we go. So it takes each word, translates it, and then joins it back into this initial string. There are some nicer ways of using some sort of thing that looks like a pipe. You can kind of chain things together with that. I'll see if I can learn how to do that, but I don't really know how to do that right now. So, okay, so let's try this out. See how translate works. We'll make translate word do a thing first. We'll say let's return. Each word is just going to return return hiya. Okay. And then we're going to translate the phrase hello there. Translate. There we go. So now I gotta evaluate this one, evaluate this guy, and evaluate that one. Good. So when I reduced it though, okay, interesting. This is where the join would be nicer, right? Because the join won't put an extra space in between each word. Let's try it. We'll just make sure that do that. So string takes any number of arguments. We'll take the accumulator, put a space, and then put the next word. Good, okay. Simple as that. There's probably some nicer way of actually using like a string interpolation in here instead. Let's see if there's anything in the docs here. String interpolation. Oh, you know what? I think I remember researching this and found out that Clojure didn't have string interpolation. There is a format which you can do that with. To be honest, ours is pretty good. So let's stick with that. Okay. So first condition that we want to check to see is if the word starts with a vowel. So we'll do another helper function, say starts with vowel. And there's this, usually if you have a predicate, which is a function that returns true or false, you have a question mark at the end of the name there to kind of indicate that it's a predicate. So if it starts with a vowel, then we'll return true, otherwise we'll return false. So, I think this is an easy one because we can essentially just grab the first letter there. We don't have to worry about a second letter. And then we'll include y and x as well. So we're going to say first and rest. Nope, that's not what we want. Okay, so first we'll just grab the first one off of that collection. Do I need to? I don't think I need to match the rest if I don't need it. Let's find out. We'll do any? I don't know. No, say okay. There's something called sum is what we want to use here. In order to see if something isn't a collection of other things, sum is the one you want to use, which is not the one with a question mark. It returns the first logical true value of pred x for any x in collection else. Nil. One common idiom is to use a set as pred. For example, this will return pred if pred is in the sequence, otherwise nil. Okay. Use a set as a pred. For example, this will return pred if pred is in the sequence, otherwise nil. Okay, so really we want to check to see if the first letter is in the collection of A, E, I, O, U, X, Y, right? Contains. I know there is something called member, but it doesn't do what you think it would do. Yeah, it's under logic as well. Okay. I believe sum is the right thing that we want, without going outside of the core library. It's fine to go outside. I mean, I'm using the string library here, but I don't want to venture off into some obscure libraries or have to install any packages or anything like that. So, I mean, I could do a regex match, but I'm also trying to avoid regexing everything. I mean, this whole problem could be solved with a single regex, but my goal is to learn Clojure and not regex. So, I think it's called a rematch or something like that. Refine, repattern, rematcher, rematches, a bunch of those things. Okay, let's stick with sum. I know that I've got sum to work for things of this sort before. So the predicate that I want here is, let's see if I can turn that into a set. So we'll try that idea of using the set as the predicate. And we'll slurp that in there. I'm going to have to convert these into individual characters. So we do that by putting slashes in front of them. Okay. And then we want to check to see if the first one is in that set. All right, let's see if that works. So we'll say starts with vowel, ear, or era. Sure, why not? Oh, okay, I didn't even check to make sure that it was not nil or something. But okay, so I'm already getting an error here. Don't know how to create iSeq from Java Lang character. Okay, so that's not working. I know that I had another exercise that I did where I used something of this sort. Anagram. Let's do this. So I'll search for when I used some. Ooh, interesting. This nucleotide here. One, okay. Okay. Oh, it's the other way around, kind of. I'm checking to see if this nucleotide is in that string. Okay. Okay. So let's just give that a try here. We'll say is first in the string of A, E, I, O, U, X. This is where they would probably do something tricky in the tests and throw us a loop with a capital or lowercase, but they're not doing that this time. So it's good. Let's give this a try now. Error. Still giving us an execution error. Don't know how to create iSeq from Java Lang character. Let's take a look again at the nucleotide here. Nucleotide was a character put inside of a set. So I'm just going to make sure that that's not what's causing my issue there. Oh, okay. Maybe it was. So we want to now check to make sure that this is, it starts with that, we want it to return true. So we want to make sure that this is not equal to nil, essentially. So we're going to put a not equal nil on the end of that and slurp in that expression. Okay, so error starts with that. Apple starts with a vowel. X-ray starts with a vowel. Yellow. Oh, you know what? Yellow is going to be a tricky one. Yellow does not start with a vowel unless the next letter. Oh, yay. Unless the next letter starts with is a vowel, is a consonant, sorry. Same thing with X. Okay, apparently X is only starts with a, is only considered a vowel if the next letter is an R. Okay. Okay, we'll just say starts with a vowel first, and we'll do A, E, I, O, U. Okay, and then we'll do a condition for starts. These are going to be a little bit verbose. All these are going to be starts with, but I'm just gonna say a vowel, and then this will be Y. What was it again? It was Y followed by a specific letter being a T. YTXR. So I'm going to say YTXR, and then we're just going to say first, second, so so easy to type those commas out, but Clojure doesn't care about commas. You know what? Actually, you know what? Literally doesn't care about commas. You can put the commas in there, and it doesn't care. I think commas are literally treated as white space. So if I wanted to put the commas in there, I could. So let's give this a try here. I'm going to say not equals nil, sum. No, actually, in this case, we want to explicitly check to see that the first is equal to and the second is equal to. So we'll do an OR. And we'll say OR equals, well, it's going to be an OR and. So let's put this on another line here. OR and equals first to y equals second to t. And then the second one will be an and equals first to x equals second to r. Usually pressing tab here does some auto formatting for us. It doesn't seem to be wanting to do that right now. I did realize that it's like picky about where I need to put that tab. Okay, there we go. I decided to put a rand in there. Okay. Everything's properly formatted. Let's give that a try. We'll see if YTXR here. Make sure I evaluate this first. Yellow should be false. Okay, I think it's YT that's, okay, YT and XR. XR is true, X anything else is false. Okay, good. So we've got vowel XTXR, or YTXR rather. I'm pretty sure I didn't need this and resting. Let's see if that was what was causing the issue before. Okay, so it was something else causing the issue. Let me double check that. If I did vowel that and then remove the X. True. Okay. That's what I thought. Good. So we've got two cases considered at the moment. We're not doing anything with those cases at the moment. Let's actually do something with it. Maybe what we want to do here is instead of just giving a true or false, we actually kind of want to take the word and transform it. Cond wouldn't be what we want then in that case. So it'd be kind of cool if I could return something. I think in Clojure, most things are considered truthy, right? So if I say, how would I check for truthiness? Equals true. Okay, that's not true. Well, because some will return. I guess what I'm wondering is if I were to put a cond of a expression that was a string, does it evaluate that thing? Let's find out. So we'll put that and say true, and then we'll say else false. Okay, well, it's because I tried to evaluate that as a function there. Okay, so it does evaluate, con does evaluate a string as true. If a test returns a logical true, con evaluates and returns the value corresponding to the expression and doesn't evaluate any of the other tests or expressions. Con returns nil. Okay, so if I returned a nil, okay, so nil is considered false. Okay, so that's good. So what I could do is I could instead just return the result of sum. Or some other transformed thing, and then if it returns nil instead, then it would just skip over that condition. So let's see if I can return perhaps back a pair, where the first one is the thing that we split off, and then the rest will be, so we will add back the rest there. So we'll just say, let's say we split off the X-ray, or I don't know, we'll do apple. So we'll say poll and then and see if they have value true. Okay, so it does. So maybe that's what we'll do. We'll take the rest there, and if this is logical true, then how does if work again? If test, then else. If this, then we're going to return first rest. Else, no. Or even more explicitly, we could just say else false. Okay. So let's see what happens if we do vowel for this guy. Returns back. Ooh, okay. A got split off there, and then the rest of it. Yeah. Let's make those strings as well. Okay, that did not do what I wanted it to. Okay, so I think what's going on is I need to apply string to the rest. Yeah, there we go. There's probably another way of doing that, but that's the way that I know at the moment. So, all right, so that's what we'll do. We'll split it off, return back the two parts to it, so that in the cond we can take those two parts and then massage them to do what we need it to do. Well, here's the thing. I don't think cond really gets the second bit that's supposed to do something with it. Doesn't have access to the return value of the cond. So cond is really still not what we want here. I'd really like to be able to oh, you know what? That's what we can do. Sum. We can use sum again. Sum will just grab the first one that evaluates to true. So if and presumably sum again is just looking for truthiness, right? So if I were to just say sum of a bunch of random stuff, sum takes a predicate first though. Oh, okay, so that's not quite what we want then. Sum needs to take a predicate first. What if that predicate was just something that was ID essentially? does Clojure have an ID? ID meaning like, okay, it has identity. Can I just say sum of identity? Sum identity, and then let's give it a bunch of stuff. Needs a collection. So we'll give it a list of false, false, I can type the word false, false, nil, apple, a, nil. Okay, I think that will work. So we just need to sum with the identity function and find the first thing that's truthy. Okay. So we'll do all the work then inside of these transformation things. We're just going to take the first one. Let's call that as a function. Take the first one, add it to the end. For a vowel, what do we need to do? If it begins with a vowel, we need to simply just put a at the end of it. Easy enough. Okay. So we're going to string first rest a. I think there was a way to, instead of getting the rest, I could have just matched on the entire collection. Let's take a look at that. Clojure pattern matching. I think it's just not really called pattern matching. I think it's called destructuring. Okay, yeah, you can just assign a name to it. Oh no, wait. My line P1 sequential. My list, can you assign a name to the entire remaining? Okay. As all. Okay. First, we don't need rest, we'll just say as word. And then we should just be able to do word with a. So let's give that a try. Whoops, gotta reevaluate it. There we go. Since it started with a vowel, just put a at the end of it. Cool. Well, I'm gonna stop the stream for now. I gotta run. But I will pick this up again sometime. This is just kind of giving an overview of my Clojure setup and how I'm attempting to do these exercises and problems. Didn't get to show you how to submit these for testing, so we'll do that in another stream. So see y'all later.